Hello everyone, my name is Mr. Lovex Izera Rurengo. Welcome to my math tutorial number 40, dated 26th June 2025. The topic of today is G.C.D and L.C.M. That's greatest common divisor and the least common multiple. G.C.D. The G.C.D for a set of numbers can be obtained by two methods. Method 1, listing factors method. This involves listing down all factors in each number, then choosing the largest common factor. For example, find the G.C.D of 8, 24, and 36. 8 has the following factors 1, 2, 4, and 8. 24 has the following factors 1, 2, 3, 4, 6, 8, 12, and 24. 36 has the factors 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now, when we assess these factors, we can see 4 is the common largest factor. It is appearing in all those three numbers, and it is the largest. That's the G.C.D of the three numbers. Prime factorization method, that's method 2. The numbers given are factorized using common prime numbers until no prime factor can simplify all the numbers further. I want us to emphasize all the numbers. Therefore, if we find that there is a factor which cannot divide or simplify any of them, we don't move forward. Each factor we select must simplify all the numbers given. Example 2. Use prime factorization to find the G.C.D of 8, 24, and 36. These are the numbers that we have already found here, and the G.C.D was 4. Let us prove it by factor method. The numbers are 8, 24, and 36. We choose a common factor. We start from the least. 2 divide 6, 8, 4. Divide 24, 12 times. Divide 36, 18 times. We also have 2, which is a common factor, which divides 4 2 times, 12 6 times, 18 9 times. Now in this case, we have a common the factor which is common for 2 and 6 can be 2, but it cannot divide 9. The common factor which is between 6 and 9 is 3, but it cannot divide 2. Therefore, for G.C.D, for us to find the G.C.D, when we reach this level where we can't get a common factor for all the numbers given, we stop at that point and consider the factors that we have already identified. Therefore, the G.C.D of those numbers is 2 times 2, which is 4. Let's move forward. L.C.M, least common multiple. The L.C.M is a set of numbers, of a set of numbers, is the smallest number that can be divided by each of the numbers an exact number of times. L.C.M can be determined by two methods as well. Number 1, listing multiples method. In this method, multiples of each number are listed, then the L.C.M identified. Example 3, find the L.C.M of 6, 8, and 12. Solution. For 6, multiples are like 6, 12, 18, 24, 30, 36 in that order. For 8, we have 8, 16, 24, 32, 40, 48 continuous. For 12, we have 12, 24, 36, 48, 60, 72 in that order. Now, in this list of multiples of given, we can identify a common multiple, that is 24. 24 is the first multiple or the least multiple that can be obtained from the three sets of multiples. Therefore, 24 is the L.C.M of these three numbers by listing multiple methods. Part 2 is prime factorization method, just as the G.C.D. The numbers are factorized using prime factors in ascending order. It means from the smallest prime factor to the largest. When a number is not divisible by a factor, the number is retained to the next level as shown below. Example 4. By prime factorization, find the LCM of 6, 8, and 12. Remember, we had already found the LCM to be 24 by listing method. Now, let's move on with this one and ascertain the answer as 24. Now, we write the number 6, 8, and 12. 2 divides all the 3 numbers. We have 2, 3, 4, 6. Then we also consider 2, which divides. Now 3 is not divisible by 2. We carry it forward to the next level. This one's divisible, that's 2. This is divisible, that's 3. We will continue with 2 because we have still a number which can be divided by 2. So that you can have 3 is retained, 2 gives us 1, 3 is retained. Now in this case we take 3 so that we can have these 2 simplified to be 1, 1, 1. Therefore, we have fully factorized when we have 1, 1, 1 at the end for each number. Therefore, the LCM is now obtained by taking the product of all of these numbers. Therefore, the LCM is 2 times 2 times 2 times 3. That is 24. The same as we had obtained in the first method. Let's move to the next level. G.C.D and L.C.M of numbers expressed as a product of prime factors in power form. This area has really raised a lot of concern among teachers and students, and the rest will do care. This area has really challenged a number of students and teachers. I come on board to share my views. We discuss so that we can get the correct answer out of it. The G.C.D is equal to the common factors with the lowest powers. If we are finding the G.C.D of numbers which are expressed as prime factors with powers, the G.C.D is equal to the common factor with the lowest powers. If we have factor 2 among the numbers, we consider 2 which is having the lowest power. If it is 3, the one which has lowest power. Because if we consider the one which is having the largest power above more than the smallest, it means that it is not a factor for this number. Therefore, it is for the G.C.D, we group for common factors with the lowest powers. For the L.C.M, we consider the product of factors involved with the highest powers. For the L.C.M, we consider all factors which appear. All factors. You might find that the first number has 2 factors, the second has 3 factors, the third has 4 or 5 factors. We must consider all of the factors, number 1. Then, in each factor, we consider the highest power. Let's take into the examples. Example number 5. Find the G.C.D and L.C.M of 2 power 3, 2 power 3 times 3 power 1, and 2 power 2 times 3 power 2. Solution. For the G.C.D is 2. For the G.C.D, 2 is the common factor among the 3 numbers. And the lowest power of 2 is 2. You can see here it is 2 power 2, 2 power 3, 2 power 3. We consider 2, yes, then the lowest power 2 power 2. Therefore, the G.C.D is 2 power 2. For the L.C.M, all factors involved are 2 and 3. When you look at these factors, we have 2 and 3. The highest powers are 3. The highest powers are 3 for 2 and 2 for 3 respectively. Therefore, the LCM will be 2 with the highest power, 2 times 3, 2 power 3, times 3 with the highest power, 2 times 2. So they are having 2 times 3 times 3 power 2. Example 6. A number n is such that when it is divided by 27, 30, and 40 or 45, the remainder is always 3. Find the smallest value of n. This is an application question from the L.C.M. Therefore, the smallest value of n is the L.C.M of these numbers plus 3. Because when the numbers are divided by this 27, 30, and 45, there is a remainder. Therefore, it means that number n is more than the LCM by 3. Let us find the LCM. We express these numbers in factor form. 27 is equal to 3 power 3. That is equals to 2 power 1 times 3 power 1 times 5 power 1. Then 45 is equal to 3 power 2 times 5 power 1. Now, for the LCM, we consider the factors involved. We have the factor, we can see 2, we can see 3 and 5. Let's take their highest power. For 2, their power is 1. For 3, their power is 3. For 5, their power is 1. Therefore, the LCM is 270. This one can be confirmed by the other way of factorizing. There's no problem. Now, the value of n is 270 plus 3, which is 273. So that when it is divided by 27, we have a remainder of 3. By 30, we have a remainder of 3. By 45, we have a remainder of 3. Example 7. Three bulbs are programmed at intervals of 35, 45, and 65 seconds. What's the earliest time they will light up simultaneously? If the last time they did this was at 10:17 a.m. This is also an application question from the L.C.M. The interval at which they write together is equal to the L.C.M. of individual intervals. Now, I've decided to use the factorizing method, the 35, 45, and 65. We take the factors here until we get all of them factorized to 1. Therefore, the LCM is 3 squared times 5 times 7 times 13, which gives us 4,095 seconds. We convert this one to minutes and seconds. That is 68 minutes and 25 seconds. We convert it to hours, minutes, and seconds. That's 1 hour, 80 minutes, and 25 seconds. Now, we add it to the time because we have been told that the bulbs lit at 10:17 together. The next time they lit, we are going to add. We add this to 10:17. We get 11:25 a.m. That means 11:25 and 25 a.m. That's when they will write together. Example 8. The L.C.M. and G.C.D. of 3 numbers are 7,560 and 18 respectively. If 2 of the numbers are 360 and 540, find the raised possible value of the third number. Note that students and teachers have used various methods to solve this question before. I'm also one of them. I've been using various methods. And one of the methods that is now common is that to get another number, when given this case, is the G.C.D times L.C.M. over one of the numbers given. This method, this formula is not consistent in all the questions of this kind. And sometimes the numbers obtained may not be the correct ones. Therefore, I want us to be very attentive. Let's discuss this so that we get out of this challenge. For example, consider the G.C.D and L.C.M. of 4 numbers are 4 and 72 respectively. The 2 of the numbers are 8 and 36. Find the other 2 numbers. Now, I want us to consider this case before we go on with the one that we're having here. Let us use the method that we have said, G.C.D times L.C.M. over the number. Now, 4 times 72 over 8, we get 36. The other number, 4 times 72 over 36, we get 8. Now, we are getting that these numbers are getting us to 36 and 38, which are already here. That's not only the case. I'm saying that we can also get other cases where we may not necessarily get the numbers we are getting, but the numbers are not consistent. I want to say that in this case, the formula does not result into other numbers apart from the one that we have been given. Now, how can we get out of this successfully? According to my opinion, the correct method is factor method. What do? We've expressed the G.C.D in factor form, L.C.M. in factor form, and the 2 given numbers in factor form. Now, let us see the possible numbers from here. How do we consider the possible numbers? Number 1, write the G.C.D. Any number that is in this list should have G.C.D in it. The G.C.D is a divisor, is a common the rest of that, it is going to divide it. Therefore, we have written this G.C.D, which is 2 power 2. I've taken power 2 because we said that the G.C.D has the common factor with the lowest power. Therefore, we cannot consider 2 power 1. That may not be okay. We are taking the one which is lowest power. That's 2 power 2. Then after that, a possible number will be 2 power 2 times 2. But when we get that one, it is 2 power 3, which is already 8. It is already here. Therefore, we move to the next one. We take that 2 power 2 times the other factor is 3. 3 with the lowest power, 3 power 1. That one gives us 12. That is not here. That's okay. That's one of the possible numbers. Now, the other number now we can consider is when we take that lowest power, lowest factor 2, decimal factor 2, with a power of 3. The G.C.D can divide it because it is a power of 2. Now we increase the power of the first factor by 1. That's now 2 power 3. Then we multiply by the next number, that is 3 power 1. We can as well multiply this one by 2 power 1. So that we end up in 2 power 4, which is 16. But that one will not be accommodated by the L.C.M. If we take 2 power 4, the L.C.M takes the factors of the highest powers. This is 2 power 3. We should not exceed the powers in the L.C.M. We should not exceed the powers in the L.C.M. We're also not supposed to get lower than the powers in the G.C.D. That's where we must operate within the limits. The power should not be less than the ones in the G.C.D. The power should not be more than the ones in the L.C.M. Therefore, we choose 2 power 3 times 3 power 1. And that gives us 24. 24 are the other two possible numbers. Now, let us get back to our question 8 that we had. The G.C.D of 18, that's the G.C.D which was 18, we factorize it. L.C.M we factorize it. 360 we factorize it. 540 we factorize it. Now there is a possible value of the third number. The one there is a possible value. Let's take the first factor 2 power 1 as it is in the G.C.D. Second factor 3 power 2 as it is in the G.C.D. We shouldn't take the power less than 2. Then after that, the next number that we should multiply is not 2 because 2 will interfere with the G.C.D. We go for 3 power 1 because here it is limited. We have 3. Therefore, this is the first number we can have, the smallest number. This one times 3 power 1, which gives us 54. That's the smallest possible number. These are the practice equations. You can pause, you screenshot them for your own practice. Thank you for watching. Thank you for listening. Thank you for sharing with me. Hope you are learning. We are learning. Welcome in advance to my math tutorial number 41, which will involve integers. Integers is very key in mathematics. Don't miss it. Feel welcome.